Okay, yesterday we were discussing about inheritance. We started with understanding inheritance by using this Sony TV class, Sony TV, and Sony Vega is extending Sony TV, right? We also understood yesterday that when one class is extending other, even the private variables are inherited, right? So here, see here in Sony TV, you have private variables width, height and is color TV. These also will be inherited to Sony Vega. Do you agree or not? Yes, private variables are also inherited, but they are not visible. Visibility is not there. So here I gave a demo yesterday. Once I create an object of subclass Sony Vega TV, what happens? First, when I create an object of Sony Vega TV, when this is executed, first Sony Vega TV class is loaded. Once Sony Vega TV class is loaded, it will load Sony TV also. See, which class is loaded first? Sony Vega TV. But loading Sony Vega TV is not completed until Sony TV is loaded, because it's extending it, right? So Sony TV will be loaded. Once Sony TV will be loaded completely, then we can say Sony Vega TV also is loaded completely. After class is loaded, then it will try to create an object of Sony Vega TV. When it creates an object of Sony Vega TV, it will allocate memory for all width, height, is color, and also has woofers, everything, all the instance variables. So I want you to assume, whenever an object is created, I want you to assume that memory is allocated for all the variables, right? Okay. Here in this case, if I do the same thing, object of Sony Vega TV is created, and second line I am calling Sony Vega dot play channels. Play channels is inherited from where? See here in Sony TV, there is a method called play channels. There are two overloaded methods which I wrote yesterday. The one which is taking int and one which is not taking anything. And Sony Vega TV here, okay, I will just remove this right now. If I call play channels, it is inherited from where? See, it's showing. It is showing that it is inherited from Sony TV, right? So play channels from Sony TV will be called. Now, when I am writing Sony TV, I just wanted to improve the way channels are played by Sony Vega TV. So what I can do, I can overwrite. So for overriding, see the shortcut, don't try to write the whole method signature. Play PLA control space and spacing play channels. Select it, automatically to write the override. So now you can edit it. You can edit it and write whatever you want. System.out SYST I am writing. Okay, this is called override annotations. We'll talk about annotations later. Annotation is just like a comment. I'll talk about annotations later, but I'll now remove it. Now I can say that I have overridden play channels method from Superclass Sony TV. Then see here, I am calling Sony Vega play channels. Which will be called? The one from Sony TV or Sony Vega TV? Sony Vega TV, right? So here, when I call play channels on Sony Vega TV, always a overridden method is called, right? Now I will change the scenario. Just tell me the answer. I am commenting these two lines, and I am saying here I am creating a reference of Sony TV, the Superclass reference I created, and I am creating an object of Sony Vega TV subclass. Superclass reference can point to subclass. Do you agree? Yes. How is it possible? Upcasting. Okay. I'll talk about typecasting later, but just let us think in a normal way, just to get a better idea so that you can answer my next questions. I tell you, reference variable is just like a remote control, and object is the actual object. As I told, objects are created on heap, and local variables is a local variable, right? Local variables are created on stack. So on stack, this Sony TV reference will be there. It will be having address of an object which is present on the heap. So whenever I want to call a method on the object, I always call on reference, right? So if I want to call Sony TV dot play channels. I can call methods by using a reference. Is it not exactly like using a remote control? See, that is actual projector is actual object I am having the remote control. If I want to invoke any operation on that projector, I will press a button. So for each and every functionality I have a button here, right? So if I want to invoke any functionality there, I have no other chance except pressing the button. Now tell me, let's assume that in my house there are two TVs, Sony TV, old TV, and I bought a new TV, Sony Vega TV. And I lost my Sony Vega TV's remote. Can I make my Sony TV's remote, the old TV's remote, point to Sony Vega TV? Yes, it is possible. If you are an electronic student, it should be possible. Yes, it is possible. If you throw your remote, new TV's remote, and use your old TV's remote and see whether it is possible or not, it's possible. Old TV remote can point to new Sony Vega TV. But tell me, in Sony Vega TV, there are new functionalities which are not present in Sony TV, right? So this is my Sony TV's remote pointing to Sony Vega. In that actual Sony TV, Sony Vega TV, there are a lot of functionalities. But in this old remote, I don't have buttons for the new functionalities. I have the buttons for old functionalities, right? So here also saying Superclass, the old TV's reference can point to subclass object. Superclass reference can point to subclass object. But can you call the methods which are present in Sony Vega TV only? No. Like in Sony Vega TV, I have a method called play games. Will I be able to call Sony TV dot play? See, play games is not even visible also. It's not there. So by using superclass reference, I can make it to point to subclass object. But by using superclass reference, I'll be able to call only the methods inherited from superclass. I cannot call the new methods. So here tell me, which play channels will be called? The play channels from Sony Vega or play channels from Sony TV? Sony Vega? Sure. Sony TV? Okay, see the point. I have Sony TV in one room, Sony Vega in one room. I bought that old TV remote and now I am pointing to Sony Vega TV. If I press this button, which will get played? Sony Vega. My remote is pointing to Sony Vega. So the functionality in Sony Vega will be called, right? So whenever I call play channels, the overridden method present in Sony Vega TV will be called. Okay, now I will summarize the concept. Superclass reference can point to subclass objects, and by using this superclass reference now, I can call only the methods present inherited from the superclass. Okay, and if one method is overridden here in the subclass, like in Sony Vega TV I have overridden, right? Now if you call that method, which will be called overridden method will be called, right? Any doubts in this concept? Okay. Now what I'll do is I'll write a method public void play. And here I'll make my play method to take Sony TV reference. Here it is coming. 1 minute. See, here I am writing a method called play, which is taking Sony TV, a super reference. Now tell me, what all objects can I pass to this play method? Can I pass Sony TV object? Can I pass Sony Vega TV object? Yes, I can pass either Sony TV or Sony Vega TV. Right. Now here in this play method, I'll call Sony TV dot play channels. Can you tell me which play channels will be called? The play channels from Sony TV or Sony Vega TV? Sony TV, sure. What if I pass Sony Vega object here? Here I didn't call till now. In main I'll call play. Okay, if I call play method and pass Sony Vega TV object, will it be fine? Yes, I can pass Sony Vega TV object or Sony TV object. Superclass reference can point to anything, subclass object also. So I may pass Sony TV or Sony Vega TV here while calling. If I am passing Sony TV, play channels method in Sony TV will be called. If I pass Sony Vega TV, play channels method in Sony Vega. So which object is passed? According to the object being passed, corresponding method can be called, right? Now I will write some program like this. See, play. I'll try to call play and pass Sony TV. Why is it giving error? Tell me now. I am calling play. In my main method I am calling play method and passing Sony TV. Why it's calling? Why it's giving error? Tell me. Yeah, very good. Main is static method. Static methods can call only static methods. It's a non-static method, right? So I cannot call. So what I'll do is, for this example purpose, I'll make this method as static. Okay. Now I am passing an object of Sony Vega, right? As Sony TV actually is pointing to Sony Vega. Now if I run this method, if I run this, see, Sony Vega TV dot play channels. Okay, I am calling here also. I'll just comment this. Now it will print Sony Vega TV dot play channels. Of overridden method is called, right? Now I will modify my program. What I'll do is, can my program take command line arguments? Yes, because main method is taking string array, right? That's the reason. I can pass some command line. Now I want to modify my program such that through command line, if I pass Sony TV, I should create an object of Sony TV. If I pass Sony Vega TV, I should create an object of Sony Vega TV. See how I do. I am expecting only one command line argument, so I can access it by using args of 0. Yes? Okay. Now see here, if args of 0 dot equals, whenever you want to compare two strings, you have to use equals method. You should not use double equals. Equals Sony. Now see, I'll just comment this one. If it is equals to Sony, then Sony TV is equals to new Sony TV. Okay. Else Sony TV is equals to new Sony Vega TV. So based upon the command line argument, I am dynamically initializing this variable Sony TV. Do you agree? Sony TV reference can point to the Sony superclass or subclass. Alright? So based upon the command line argument, I am initializing it with either Sony TV or Sony Vega TV, and I am passing this play. I am passing a same variable to play. Okay? Now will you be able to tell me here, when I call Sony TV dot play channels, will you be able to tell me which method is called? The method from Sony TV or Sony Vega TV? Depends on runtime. While running, if I pass Sony as command line argument, Sony TV is pointing to. So here Sony TV object will be passed. If I pass something else other than Sony, for this method Sony Vega will be passed, right? So until runtime, you cannot say which method is called here, right? I am calling a method by using superclass reference. Until runtime, you will not be able to tell which method is actually called, whether the method from superclass or the method from subclass, right? So same method name is same, but you are not able to decide until runtime which method is called. Method name is same and which method is called depends, and you will be able to decide only at runtime. Same thing, many forms. What is it? Same thing, many forms is called as polymorphism. Method name is same, but its behavior is different, and that behavior can be predicted at runtime only. So this is called runtime polymorphism. Why am I able to observe runtime polymorphism? Because of overriding or not? Suppose in Sony Vega TV, I don't override play channels method. I'll comment it. In Sony Vega TV, I commented play channels. Now tell me, will you be able to tell which play channels is called the play channels from Sony TV or Sony Vega TV? Sony Vega anyway, it's not there. So you can tell that play channels is from Sony TV only. Are you able to observe runtime polymorphism now? No. At compile time only you are able to say which play channels method is called, because I need to override. If I have overridden again, you cannot say no, right? So this is an example of runtime polymorphism. You are able to observe runtime polymorphism because of overriding. If you don't override, you cannot observe runtime polymorphism, right? And see here in Sony TV, I have two methods: play channels, which is not taking any parameters, and play channel which is taking it, right? Simply forget all. I'll just forget all this. I'm adding block comment, and I'll say Sony TV is equals to new Sony TV. Now I'll call Sony TV dot play channels. Tell me which method is called? Okay, Sony TV, and there are two play channels, one which is taking it and one which is not taking it. The one which is not taking it is called, suppose if I pass int, the one which is taking int is called. So again here also method name is same, play channels, but its behavior, which code is executed exactly, is decided at compile time or not. At compile time only you can say, if I am passing parameter, the one which is taking int is called. If I am not passing any parameter, the one which is not taking anything is called, right? So at compile time only I am able to say which method is called, right? Right? One method name, different behaviors. Again here also polymorphism, but this polymorphism can be observed during compile time only. So this is compile time polymorphism. So why are you able to observe compile time polymorphism? Because of overloading, right? So you are able to observe compile time polymorphism because you are having overloaded methods. See, it's a common practice to you to tell, if somebody asks what is an example of runtime polymorphism, what is your answer? That is wrong answer. Overriding is not example of runtime polymorphism. You will be able to observe runtime polymorphism because of overriding. That is the exact answer. Don't say blindly. Okay, many people accept that answer also, but that is not correct. You will be able to observe runtime polymorphism because of overriding. This is correct sentence. Similarly, you will be able to observe compile time polymorphism because of overloading. Don't say overloading is an example of compile time polymorphism. Okay? Any doubts in the concept? Runtime polymorphism, compile time polymorphism? Right? Is it clear? Any other doubts? System.out.println is example of overriding. How can you say? Let me continue this. Yesterday we understood the constructor calling chain also, right? When I create an object of subclass, see here, I am creating an object of subclass. First subclass constructor is called. Sony Vega TV constructor is called. What is the first line inside Sony Vega TV constructor? First line, whether I write here or not, it is called to super. Whether I write here or not, there is super here. Who will write super if I don't write? Compiler. When it is converting .java to .class file, it will insert the code for super. So whether you write or not, first line will be called to super. So super, what is super for Sony Vega? Sony TV's constructor is called. Here tell me, what is the first line of Sony TV constructor? Super. Who is the super for Sony? Object. If a class is not extending anything, it is implicitly extending java.lang.object. Okay. Tell me one doubt I have. I am using a class called system. What is my current package? com.accenture. Yesterday we understood, if I am using a class which is present in other package, I need to write an import statement. I am using system here. This system is present in which package? I am keeping the cursor here, see? Java.lang. But did I import java.lang? By default, java.lang package is imported. You need not import it explicitly. Who is writing that import statement? Compiler will write it. So by default, see, java.lang package is imported. Similarly for string also. String also is present in java.lang package. That's why we are able to use string. And one thing I want to tell you, here in overload, when I'm talking about inheritance, tell me, can I make my constructor private? No? Constructor should be public? Can we make private? Okay, very good. Let me check. Private I'll make. Oh, here there is no compilation error. But if you see Sony Vega TV, here it is giving compilation error because super, the first line of constructor is super, but that constructor is not visible. It is there, but it is not visible. So if I don't want to inherit, can I make my class? Can I make my constructor private? Let's assume I don't want this Sony TV to be inherited. Is there anything? Is there any issue if I make my constructor private? No? Yes. Yes. I'll tell you. I'll talk about this private constructor later. Okay, I'll make it public now. Generally, the constructor can be public. Even I can make it private. There is some effect of making my constructor private. I'll talk about it later. Now, see here in Sony TV there is only default constructor. Can I give parameterized constructor? Yes. So what I'll do is I'll write a parameterized constructor. See, now try to understand the concept. You need not type today. See, I'm giving parameterized constructor. Going to source, generate constructor using fields. This you have done yesterday. I want a constructor which will take only width for simplicity. Okay. Now there are two overloaded constructors, right? There are two overloaded constructors. One Sony TV constructor which is taking int and one which is not taking anything. In the subclass, tell me which superclass constructor will be called here? The one which is not taking any parameters. Suppose if I want to call the constructor which is taking parameters, what can I do? Pass some parameters to super. Super, and suppose I want to pass a 10. Right? So whenever you want to call non-default constructor in superclass, you have to explicitly call super with passing parameters. If you want to call implicit constructor or default constructor, no need. By default it will call. Right? Yeah. Yes. See, this is default constructor. Constructor which is not. This is default constructor. The constructor which is not taking any parameters. But if you are using this default constructor, okay, I'll just remove it for clarity. Here, what will be the width if I use this constructor for creating Sony TV object? What will be the width? I'm not initializing width. Constructor is for initializing the instance variables, right? Here in this case, I am not initializing width, height, and each color TV. So they will be having default values, right? So I want to initialize the instance variables. I want to explicitly initialize width when creating object. So I took a constructor. I wrote a constructor which is taking width, right? Okay. Even though I don't write this, it is implicitly there, right? Okay. By default, the first line inside any constructor will be called to super, even I write it or not. I removed it now for your clarity. So this is another constructor, this is another constructor. Two overloaded constructors. Right? If I want to create Sony TV object, I can decide whether to use this constructor or this constructor. It's my wish. Right? There are two ways of creating Sony TV object. Right? Now, coming back, Sony Vega TV is extending Sony TV. And now, if I don't write anything here, what will happen? I try to call the default super, the default constructor. Now, if I want to explicitly call the constructor in Sony TV which is taking int, I should explicitly write super of 10, right? But generally, what we do is, here I am hard coding 10, right? Here I am hard coding 10, so I can take this from user int width and I can pass the same width. So now when user is creating Sony Vega TV, he has to pass the width. I can pass here whatever I want. The same value, I am passing 20 here to the constructor of Sony Vega TV. Same value will be passed to super and width is initialized. Okay? Just check any doubts. Yes. And one more thing here. Here, is this play channels overridden? Play channels is overridden. In Sony TV you have play channels. And in Sony Vega TV also you have play channels, right? But from here, suppose in play games, if I call play channels, which will be called the one from Sony TV or the one from here, Sony Vega. The local one will always be given preference, right? But what I want is from play games, I want to call the play channels present in Sony TV. So super dot. If you want to distinguish between the local method and superclass method, then you have to use super. If you are using just play channels, it is equivalent to calling this dot. By default, if you call play channels, it is this dot, the current object. If you want to explicitly say the one from superclass, you have to always use super dot. Okay? Any doubts? Okay, see here, another concept. I have Sony TV. In Sony TV, I have a method called play channels. I don't want the subclass to override this method. Any subclass should not override this method. So what I can do is I can make it final. If I make my method final, the meaning is it cannot be overridden. See here in Sony Vega, it is giving error now. It's saying some error. Cannot override the final method from Sony TV. Remember, when you are writing your own class, if you don't want any subclass to override it, then you have to make that method final. Okay? Final methods cannot be overridden. Okay, fine. Okay, now I don't want to make it. Okay, understood final? I am removing it. See here, I don't want anybody to inherit my Sony class. Nobody should subclass my Sony class. So I can make it final. If I make my class final, the meaning is it cannot be inherited. See here again it is giving an error. See what is it saying? Here only it is giving an error. The type Sony Vega cannot subclass the final class Sony TV. So we understood two meanings of final.
So if I am giving private to class, then
Wait.
cannot
Class cannot be private first of all. Class cannot be final. I'll talk about access specifiers later. Okay. Now I don't want to make my class final. But still I want to avoid inheritance. How is it possible? Just think and tell. I don't want to make my Sony class final, but still I don't want anybody to inherit it. Is it possible? Huh? But it still can be inherited. I can extend. What if I make my constructors private? If I make all my constructors private, see here, the first line inside the constructor will be called a super. It is not visible, so you cannot subclass it. But there is one problem. Can I create an object of Sony TV now? Constructor is private. There are two constructors, all the two constructors are private. Will I be able to create an object of Sony TV? No. So if constructor is private, can I create an object? No? In the same class I can create, but outside I cannot create. So if I have a private constructor, is it good? Because you will not be able to create objects, right? But somehow outside Sony TV I want an object. Outside Sony TV I want to get an object of Sony TV. How is it possible? Got me? Okay. See, okay, forget about this one, forget about Sony TV and everything here. Let me create a class called X. Simply I'll create a class called X. And I'll make this constructor private. Now I want object of X outside it. Will I be able to create object of X outside? Suppose I'll write a class, another class called demo. I'll take main. Here, can I create a reference of X first of all? Reference can be created. But what about object is equals to new X? It is not visible, is it? So now somehow I want an object of X in demo. How is it possible? Just think logically and tell me. Now I want my constructor to be private only, but still I want an object. Okay, as she was saying, I can have a method here, public, return type is X, and I can write a method called get instance or any method. Okay, and here I will return new X. Is it okay? Private, this is private, constructor is private, so inside same class it can be accessed. So I am able to create an object of new X, right? Now in demo, if I want object of X, I have to call that method X. See, if this is non-static method, right? Non-static methods have to be called by using objects. But to get object, you have to call this method. Chicken and egg problem again. right? So we have to make it static. Okay. Sir. Static. So now if I want an object here, what I can do, x dot get instance, I can get an object. Yes, whenever I call get instance, this method will be called in x, get instance will be called in x. Here you are getting new object and returning it, reference of object you are returning it. Yes, so this is a way you can create an object of a class when you are having a private constructor. But now tell me how many objects are created. How many objects are created of x? How many objects of x are created? How many times I call? 1, 2, 3, 4, 5, 6, 7 times I called. How many objects of x are created? 1. Right? Every time I call get instance, is it not creating new x? 10 times I called, 10 times new x is created. 10 objects of x are created. Right? There is no difference. Even though I am not taking it in JVM, object is created, but you are not holding it in a reference. But objects are created, right?
Static provides the formula.
Huh?
Static provides the formula.
Static method. Variable is not static. Okay, now the requirement is I want only one object of x to be present at any point of time. Okay? Whenever I call x dot get instance, you should not create a new object every time. I want only one object of x to be created. So see here what I'll do. I can create private static x. I created a static variable of same type. Okay? And how can static variable be initialized? Where I should write the initialization code for static variable? Static block? Yes. Static block. This will get executed when class x is loaded, right? So here I can say x is equals to new x, and whenever I call get instance, I will return only the reference x, right? Now see the case. Once I call x dot get instance, for the first time whenever you are using x, it will be loaded. When the class x is loaded, first variable x will be allocated, right? Immediately static block is executed. So x is initialized with this object's reference, right? And whenever you call get instance, you are returning the same reference. You are not creating a new object, you are returning the same. So now how many objects of x will be created in this case? Only one. So a class for which only one object can be created is called as a singleton class. Singleton class. Singleton. There is a design pattern actually, but this is a most commonly referred design pattern. A class for which only one object can be present is called as a singleton class, and this is the way to create a singleton class. See, if somebody asks you how do you create a singleton class, make the constructor private and write a static variable which will return the reference of that object. This is the way to create a singleton class. In interviews, it's a common question which is being asked. Like if you are going for project interviews, then this can be asked. Just see it for some time and let me know if you have any doubts.